Good day, students. We are now going to again continue with the chapter 1 because we have not completed very important issues of that chapter. So I will start from where we have left off, that is in my previous video. So here I will start with some of the examples of applications of the identity that we have learned in my previous video. I would request all of you to please study that the previous video which have just been put in our channel just a few days ago. And if you study that video plus study this video, you will get a very good idea about what are the problems which are associated with the number system. So let us start with example 16. So we are going to start with example 16. So example 16, and continuing with chapter 1 of the book, mathematics book, and that's it says simplify the following expression. Now we must know what is the meaning of simplifying. What is the meaning of simplifying? Simplifying means, first of all, separate the rational and irrational parts. Separate means separate the rational and irrational digits or identities, digits or oblique identities. Okay. Now let us, when we do the first one, it says that multiply 5 plus root 7 into 5 plus, I have said root 7 and writing root 5. So be careful when you also do 2 plus root 5. So I have to multiply the way it is being multiplied before. So you see, multiply, first take 2. So that gives you 10 plus 2 root 7. Then you multiply it by root 5. That gives you 5 root 5 plus root 7 into root 5. Okay, so what do you get out of that? You get out of that only further this thing that you can do is there is nothing, all these and this, they are all irrational. So this part of it is all irrational. This is the only rational part of it. So I will write 10 plus 2 root over 7 plus you can write 5 root 5 plus root of 35. So this solves this problem, right? There is nothing else you can do about it. Okay, next one is little bit easy. 5 root 5 into 5 minus root 5. Okay, 5 minus root 5. So I would like to erase this so that you don't get confused with this one. So let me erase this part of it so I can keep on continuing with it. Sometimes this gets confusion. So this would be equal to a square. So this can be a square, a plus b into a minus b. So that gives me a square minus b square. So this would be 5 square minus root 5 square. So that will be equal to 25 minus 5, that is 20. So this is totally rational, right? So there is nothing, no problem about it. Okay, now I don't need this part of this thing, so you have already seen what is to be done, so I can erase and recover this part of the board. So I will use the next one to do the next one is, that was number 2, this is number 3. Number 3 says root 3 plus root 7 and its square. So how do we do it? Again, a square minus b square, a square plus b square formula. We add that would be equal to root 3 square plus root 7 square plus 2 into root 3 into root 7. So that would be equal to 3 plus that will be 7, that will be 2 into root of 21, that is equal to 10 plus 2 into root of 21. Is that correct? This is very, very straightforward. The next one is this one, that we have done it earlier. So that will be number 5, that will be root of 11 minus root of 7. Okay, and now here only this thing has been flipped, that means the minus has come before. So 11 plus root of 7, that will give us, so let me erase this part because there should not be any confusion between digits and saying how did that come and this one. So again that will be 11 root 11 का square minus root 7 का square, that is 11 minus 7, that is equal to 4. So this all came as a rational number. So even we started with irrational number, that came into rational numbers. Okay, now then it is very interesting point, and I will, this is, instead of representing the way it has been represented in the book, I will represent it in a different way. I will now use this example to explain to you how to represent 1 upon root 2 on the real number line. How do you do that? Because it's very difficult. We know how to represent root 2 on number line. There is no problem. But how do you do 1 upon root 2? The best thing to do is always in such cases, first job is to rationalize the denominator. And how do I do it? I can only bring from root 2, either I square it or I multiply and take this one on this thing. I can do it two ways. Multiply both denominator and numerator by root 2. So what do I do? So 1 upon root 2 is equal to 1 into root 2 into root 2 into root 2. Okay, so what does that gives me? That gives me, this one will be root 2 and this one will be 2, which is same as half into root of 2. So in the number line, I will put root 2. I'll find out the position of root 2. So let us say this is about root 2. this is about root 2, this much, then I'll take half of it, So this would be the position of 1 upon root 2. Isn't it interesting? So you can do any 1 upon root 3, you can do the same thing. You can again rationalize the denominator, and you can do the same thing. So this is one of the unique techniques of presenting this one. So rationalizing the denominator, rationalizing denominator is very, very important part of dealing with roots of this kind of with radical or digits with radical signs. Okay, I hope you remember what the digital sign means. Okay, if you don't remember, please refer to my previous video on this subject, just before this video. Okay, now it says example 18. Example 18. What does it say? It says rationalize. Rationalize the denominator of 1 upon 2 plus root 3. Very easy. What do you do? What do you do? You have to do that. So I will take A, I'll take it B, I will multiply it by A minus B, so that I get A square minus B square. So, okay. So that will be, then I will do 1 upon 2 plus root 3, multiply these into 2 minus root 3, in order to not change the identity of this number, I have to multiply the top one also 2 minus root. Okay, so utilize this identity. So this one at below becomes 2 square minus 3, okay, because this will be, b square will be minus, and this one on the top will be 2 minus root 3, okay. So this should be what? This should be 2 minus root 3, then this is 4 minus 3, that is 2 minus root 3. Okay, so we can always find out this one. If at the denominator you have 2 plus root 3, at the numerator you will definitely get 2 minus root 3. So in some cases, in MCQs, you don't have to go through these calculations and all that. If you see it is plus here, you put a minus 2 minus root 3. If you see it minus, you put 2 plus root 3. Okay, now let's go through, this is done. Now let us go through another one, which is example 19, which will be example 19. Okay, what would be the example 19? It says, example 19 is again rationalized. So this is 5 by root 3 minus root 5. Okay, is that all right? So what I'll do, without this thing, I'll multiply it root plus 5, and here also I will multiply root 3 by root 5, which is given, multiply by root 3 plus root 5. I have already discussed the things that we are going to do. So this will be 5 into root 3 plus root 5 into here, this will be square of this should be 5, and square of again root 5 is minus 5. Minus was already there, so this would be, so 5 into root 3 plus root 5 divided by minus 2, so that you can take it 5, use the convention, root 3 plus root of 5. So this is done. Okay. Now again the same, in the same vein. So this was example number 19. Okay. So this is done. Okay. So this one is no issue. Okay. Now again we going to 1 by, this is will be 20. So that was 19 and now we are going to 20. Okay. What is 21? 1 upon 7 plus 3 plus root 2, that would be again minus, so this should be 1 plus minus 3 into root 2, because 1 is only there, so this should be 7 plus by root 2 into 7 minus 3 root 2. Okay, done? So what would be, this one would be equal to, this doesn't make a change, so this will continue to be repeated like this. This would be 7 square plus, 7 square minus 9, 3 into इसका square. So let us do it, this 2 का square कर देते हैं यहाँ पे. So that would be 7 minus 3 root 2, and this would be 49. This would be 9 into root 2. So that will be 7 minus 3 root 2, and this would be 49 minus 18. Okay, so 49 minus 18. So this would, let's complete it here itself. 7 minus 3 into root 2, and this one will be 1, and this one will be 31, right? Okay, now this is all these examples, this thing. So this is, we have been doing it what is known as rationalizing of denominator, and we told you what are the reasons and advantage of doing it. Okay, so we have done the examples, 20 examples. Now we come to exercise 1.5. Exercise 1.5, right? Okay. Now what does it say? It says first question, classify the following numbers as rational or irrational. Okay, first one, 1, 2 minus root of 5. Definitely it contains root 5, so this is irrational. Okay, done. Number 2, it says plus root 23 minus root of 23. So do the operation. That is 3 plus root of 23 minus root of 23. So these and these cancel. So this would be rational. So this was irrational. This is irrational. Okay. Now we are going to go to the third one. Third one is again 2 root of 7 divided by 7 root 7. So these two cancel and that will be given 2 by 7, which is irrational. Okay, fourth one, 1 upon root 2. So that you can rationalize the denominator, so it will be equal to 1 into root 2 into root 2 into root 2, that is half of root 2, so that will be irrational. Irrational, right? Okay, done? Okay, this is 4. I have got only the 1. Many people say they are very much afraid of pi. I don't know what is there to be afraid of. It is anything but an irrational number. All of us, we know about it. So let us see, let us do that. So that would be 2 pi. So this is equal to, since pi is irrational, as pi is irrational, therefore 2 pi is irrational. So question number 1, then again it says come, we have done it in the example itself, so we are going to go to question number 2. So we are going to go to question number 2. Question number 2, it says simplify, we have talked about this, simplify each of the following expressions and that is, it says 3 plus root 3 into 2 plus root 2. So again a plus b into cd, like you can take it a plus b into c plus d. So you do the similar thing, multiplied by 2, that is 6 plus root of 3, 6 into root of 3, 2 into root of 3 plus 3 into root of 2. We have multiplied by plus, I can accommodate it here, root 3 into root 2. That is equal to the same thing, there is no change. You can write it down again, 6 plus root 3 plus 3 into root 2 plus root of 6. Okay, so this is done. Okay, next one again very easy. This is easier than this. So this was number 2. We have done the previous one. This is number 2. Okay. Now we will go for number 3. Now we will go for number number 1 we have gone. Now we will go for number 2. That would be root 3 into root 3. Here 3 minus root of 3. Okay, a plus b, a minus b. So a square. So that would be equal to 3 square minus root 3 square. So this would be 9 and this should be minus 3. That would be equal to 6. So this is done. Now we will go for number 3-1. This is one line questions. Very, very important, as they come in MCQ. This kind of question you can save time and utilize in other cases. So this is root 5 plus root of 2 and iska square. A square plus b square up karo. So this is root 5 ka square plus root 2 ka square plus 2 into root 5 into root 2. तो क्या हो गया, दिस इज 5 plus 2 plus 2 into root of 10, that is equal to 7 plus 2 root 10. So this is done. Okay, then we can go for so the fourth one is very simple. Again, we have done similar kind of thing earlier, which is same thing as question number 2. There it says root 5 minus root 2 into root 5 plus root of 2. So that becomes again a square minus b square, a square minus b square, 5 square minus root 2 square. So that is equal to 5 minus 2, that's equal to 3. So that takes care of question number 2. Now let us see question number 3. Interesting. This says that why that pi is different as ratio of pi is equal to a ratio of circumference to diameter. Circumference to its diameter, the same diameter of the same circle. नहीं दूसरा किसी का, it's not somebody else's diameter, son of the same circle. Then why it is irrational? Then why irrational? See, whenever you measure the diameter and the circumstances, this involves the measurement. This is only a ratio. There is no unit. So this is the ratio of the two, and that will be that will relate to some amount of irrational in the sense. Because why it is irrational? Because the decimal expansion, does not terminate or repeat. So there can be error in the measurements on the both sides by a very minute amount, and that will result in this thing. So this is question number, sorry, this is no longer 2, it is 3. This question number, this is over. Now there is question number 4. So this we can think about, and you can add a many number of times of thinking about it, that why pi should be irrational. What are the reasons for pi being irrational? Okay. Question number 4, it says represent root of 9.3 on the number line. Okay, so what we do first? First we have to draw this number line. So let me draw this number line. Okay, I should have to draw it firmly, otherwise the line will go here and there. You can see it is happening already here. Okay, so this is my number line. This number line looks like this. Okay, now I have to go around and take what is known as I have done it before, I have to take 9.3 on this number line. So let me start from here. Okay. So I will take these units from here, and that will be reasonable, faster and easier. So I will take this point here, I will take this point here, this point here, this here, this here, this here, and this here. So how many I got? So let us take this as 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Okay, I have to go few more. Okay, 7. So I will go up to, this will be 8, this will be my 9, and I will go up to 10. Let me take up to 10. Okay, so this would be 8, this would be 9, and this will be 10. Okay, 9.3, so it should be in between somewhere here. So let me take this one, okay, as 1, 2, 3, 4. So it was divided into that. So let me go around here and see I can get any help in this direction. Okay, this is divided into 5. So I can take 1, 2, and 3. So this is 3. So this is 3. Okay. So to the best of my accuracy, I can get this one at 9.3. So from here to here, this is 9.3. So this is first what I have done. I have taken 9.3. Okay, now what I have to do, I have to go another unit. I will take another unit, same unit, another unit I will take. So that unit from 9.3 I will take. So if I take that unit, so this unit becomes here. Okay, so that unit is here. You have to be, this geometry, you have to be a little bit accurate. If you are not accurate, you will get something different value. So this point is, please see this one. This has been done very nicely in my previous video. Okay, so this is 1 unit, 1. And this is 9.3 units. Okay. Now what you do, you take the whole thing. Okay. So this became, this one is of interest to us, not the 10. This point is of interest to us. This point and this point. So I am using a different colored chalk. So this is 9.3 plus 1. So 9.3 plus 1. So this is 10.3. Half of 10.3 is 5.15. So 5.15 somewhere here, and I will make it at the center, and I will try to draw a semi-circle. So let us say I did a good job. I am very, very happy with myself. Okay. Now from 9.3, you have to draw a perpendicular. So draw a straight perpendicular and let it meet it here. So it will meet here. So I have to now measure this distance from here to here. So I have to measure this thing here. So it comes out somewhere at 9.05. So my measurement is, this is 3.05, not 9. So this distance, this from this to this distance is is 3.05 because it was coming in between 3 and 3.1. Now, if this is, so I am what by measurements. So on the number line, what I have to do? This says represent this on number line. So I take this and these I will do it here. So this is representation. Okay, from here to here, this would be my representation. I have represented on the number line. Now let us see 3.3. If I multiply 3.05, whether I get this. Okay, let us multiply this to here. I'll go much more further down, so I will go up a little bit. I can eliminate that. 3.05 multiply into 3.05. What is this? 25, 15. 0. Again 15 into 9. Okay. What does it give me? 5, 2, 0, 3.9. Not bad, not bad. 1, 2, 3, 4. 1, 2, 3, 4. Okay. This is also satisfied. See, if you can do it, you can do a very, very good job on this issue. So, even with these rudimentary facilities, it is possible for me to obtain this particular value. Okay, now this finished my, now we have to go to rationalize the following. So that will be now, that was question number, this was question number 4. I am sorry, I should have changed it earlier. This is question number 4. This whole thing is question number 4. Okay, represent on the number line. Acha, okay. Okay, last, this will be our last, this thing, we'll pick up the remaining on our next video. And this, because that video which will be following is much more important. This puts up a very good base for this one. Represent the rationalize. Again, this is rationalize. Rationalize the denominator of the following. And that would be what? First one. 1 upon root 7. We have done it before. So that will be 1 into root 7 into root 7 into root 7. That is equal to root 7 by 7. Okay, that takes care of 1. Then it should be root 7 by root 7. 2 would be again 1 upon root 7 minus root 6. That will be 1 into, as I have said, matrix plus by root 7 plus root of 6. And this would be 7 root 7 square minus root 6 square, root 6 square. So that would be root 7 plus root 6, or niche will be 7 minus 6, that is root 7 plus root 6. This is done. Number 2. How many are there? There are 2 more. So it will be done in a jiffy, very fast. Okay, so this is done. This is question number, again I have to do it, that was 4. This is question number 5, we are doing it. So I always forget to change the question number. So this is number 3, and this would be 1 upon root 5 plus root 2. So again, this would go as a minus because we are going to multiply by root 5 minus root 2 and minus root 2 and this would be root 5 plus root 2 into root 5 minus root 2. That would be equal to root of 5 minus root of 2 into root 5 square minus root 2 cos square. That would be equal to root 5 minus root 2. This is 5 minus 2. That is equal to root 5 minus root 2, and this will be 3. Okay, this is done. Okay. Next one, that is we will, after this we will stop it here for this video, because I think we have discussed a lot of this thing, and if you can assimilate them, then you will not have any times, whether it is MCQ or any other way of judging your capability, you should not have any problem. So again we go through this thing, 1 into root 7 minus 2, this will be plus 2, and below it will be root of 7 minus 2 into root of 7 plus 2. So that would be equal to root of 7 plus 2. I don't have to put a bracket here. So this would be 7 root of 7 square minus 2 square. So I am already writing the square. So this would be equal to root of 7 plus 2, and below it will be 7 minus 4, because that will remain as 7. So this would be root 7 plus 2 divided by 3. Okay, done. So we will stop it here today, and I think this should be about a 50 or 55 minutes video, and it will take you time to assimilate this. I will also take this opportunity to thank you for viewing this video, and as well request you to like the video, and if you have not subscribed to my channel, please subscribe to the channel. Thank you very much.